All right, so yesterday we majorly talked about inequalities and then we started talking about systems. So before we go into more inequalities, let's talk more about the actual system of equations. So let's do exercise 2 together on page 4. So if I'm talking system of equations, remember the only ones we're going to care about are quadratic linear systems, meaning one equation is a quadratic and one equation is a linear function. All right. So if we solve this by hand, what do you think I'm going to have to do to these two equations? Claire?
Minus 8x. Are you going to set them equal to each
Right.
other?
So we're going to set them equal to each other first, then we start the whole solving process. So we're going to do x squared plus 4x minus 15 is equal to 8x minus 3. And the reason we do that is because both of them are equal to y. So by substitution, we can set them equal to each other. So then, just like Claire said, we go into the solving process. So we'll subtract the 8x and add the 3 to both sides. That goes away. I get x squared minus 4x minus 12 is equal to 0. Now, most of these, like I said, we'll be able to solve by factoring, so that's what we're going to do. So, if I was to factor this, all right, I have negative 12 on top, negative 4 on the bottom. We're two factors in negative 12 that will add to negative 4. 2 and negative 6. Now, for time's sake, because I know y'all can factor, I'm just going to give you the factors. Okay, does anyone actually need to see me the whole process of factoring? Are you guys good with that? So do you guys need to see the process of factoring? Okay. So I'm just going to give you the factors. So it'll be x minus 6 times x plus 2 is equal to 0. So if we set both equal to 0 to solve, x has to be equal to negative 2 and positive 6. Now, we're not done because with systems of equations, we also need a what value? So not only do we need an x, we also need a what? A y. So remember, to get your y values, you plug both of them back into one of the equations. It doesn't matter which one. I typically say do the linear one because it's quicker. All right, you can absolutely do the quadratic one. You should get the same thing with either or. So if I plug this back in, 8 times negative 2 minus 3, that would be negative 16 minus 3 or negative 19. 8 times 6 minus 3, that would be 48 minus 3, so 45. So these are our y values. So I would say that the set xy is equal to the points negative 2, negative 19, and 645. So in other words, these would be our points of intersection. Yes, ma'am. Again, you can pick either equation. So, for example, let's say I took the negative 2 and I plugged it into the quadratic. I should also get negative 19. So, if I do negative 2 squared plus 4 times negative 2 minus 15, this would be 4 minus 8 minus 15. So, 4 minus 8 is negative 4, minus 15 is still negative 19. So you get the same thing regardless of which equation you pick. I typically, my rule of thumb is pick whichever one you think is easier to put into. Or the one that you think you'll have less room for error plugging into. All right, any questions on that? All right, so now we're talking about systems of inequalities. So yesterday we kind of had an uglier one. I want to do one that's hopefully a little bit better, but we're going to do it anyway. All right. So on top of doing it in your calculator, I also just want to show you how you could do it by hand. It's basically the same thing as if we were solving an inequality. All right, just a quadratic inequality. So first things first, you need to make sure that every piece is in standard form. So linear function's fine, but what about this one? Right, we got to expand the vertex form. So in other words, we got to do a quick box method of x minus 5 times x minus 5 and then subtract the 1. So I'm not going to do the box, but it would be x squared minus 10x plus 25 minus 1. So this would be x squared minus 10x plus 24. So I'm going to take this and set it equal to the negative 3x plus 8. So if I do that, I would add the 3x to both sides. Don't worry about it right now. We're just saying them equal right now so we can find the points of intersection. So these signs will come in when we graph it, but first we got to find the points of intersection. Now you could do it in Desmos, but I want to also show you guys how to do it by hand so you get used to it. So that goes away. This is x squared minus 7x plus, 16. Now, here's the problem. Are there any factors of 16 that will add to negative 7? No. So what we got to do? Quadratic formula. All right. So, real quick, quadratic formula, what is it? Good. So, if I plug everything in, A, B, C, my A is 1, my B is negative 7, my C is 16. So this would be negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 16 all over 2a. All right. So then this would be 7 plus or minus the square root of 49 minus, is it 64?
Yeah. Yes.
Hold up. Yeah, I know. That shouldn't be no solution. Or maybe I might. Okay, so pivot for just a second. Let's look at the graph side. Well, no, I'm just checking something because I'm just making sure that it's not no solution because it might be no solution. All right, shh. So this would be, what is it, negative 8x? What's the system, guys? Okay, so I'm going to plug it in. So negative 3x plus 8. And then x minus 5 squared minus 1. Okay, so yeah, that's what I thought. Yeah, it has. So why am I getting. No. I know what it is. Okay. So that's what I thought. All right. So this one is kind of a bit of a special case when we're solving. So we're still going to keep solving, but if we look at the graphs, just to give us an idea what's going to happen, what do you guys think is going to happen in terms of the system of equations? So if I zoom out, so if I'm talking system of equations, not system of inequalities, I'm talking equations. What do you think is going to happen? They're not going to intersect. All right. So these are not going to intersect. So technically, if we're talking system of equations, there's no solution. But we're just going to keep on trucking. Because system of inequalities is a bit different because we're looking for where they overlap. All right. So if we keep going, this will be over. I don't know why I wrote A, but that should be 1 all over 2. So it should be 7 plus or minus the square root of negative 15 all over 2. So that would be 7 plus or minus I square root 15 over 2 is equal to x. All right. Now, there's obviously no way we can plug that back in. So this just lets us know that in terms of the system of equations, since it has that I in it, all right, it just means in terms of the equations, there's no solution or no real solution. However, that cannot be said for, say, our inequalities. So I'm going to do a quick graph of these first. So let's see. For the first one, I got an x-intercept at positive 8. My rise over run is down 3. So 2, 3 over 1. Down 3, so 2, 3 over 1. Down 3, 2, 3 over 1. I'm just going to keep doing that until I run out of graph. Now, based off of the inequality, is this going to be a solid line or a dotted line? It's solid because of that equal to. Shh. Now, shading, we're talking greater than. So do you think I'm going to shade to the left or to the right? To the right. Guys, please stop talking. So I'm going to shade over here to the right. Because it's greater than. So that means values above the line. And technically, even though it's really hard to tell, I like to use my arm. So if it's descending, it would be up here. Now, the other is our quadratic. So it has a vertex at 5, negative 1. So 5 and then negative 1. So right here. It has zeros at 4 and 6. And the y-intercept is way up here. So we got a while. But this gives us a general idea of what it looks like. Desmos. Well, that, and it's already in vertex form, so that gave me the vertex. I can, the original. On this one, probably, yeah. It's a quiz, not a test, though. But anyway, so in terms of shading, All right. So it's less than the graph. So think about this logically. Okay. If I'm talking less than the graph, would it be in between the parts of the graph or would it be outside? It would be outside. All right. So I would shade everywhere outside that graph. So remember, our system is where the overlap is. All right. So we can double check this in Desmos. So Desmos will give us a little bit of a better picture. So I'm just going to type in front of this our inequalities. So this is y is greater than or equal to, and y is less than. All right. So if we look at this picture, our system of solutions will be where it's greater than all of this, but then it avoids this section that is what's it called? It avoids the section where the greater part of the graph is. I can't speak English right now. But so how will we write this? All right. Basically, how we would write this is that it would be all real numbers. Can someone shut that door, please? It would be all real numbers where y is greater than or equal to negative 3x plus 8, except when y is greater than our original. So x minus 5 squared minus 1. So for this one, it doesn't actually have values that we can actually say it's between because it's a no solution. But we can still get a generalized statement of where we can figure out where our set is. So it's any real number. Our solutions are in any real number where y is greater than or equal to negative 3x plus 8, except it excludes this section right here. So this one little pink section in the middle, that's what it excludes. And that would be when x is greater than or equal to, because it was. So it'd be equal to because, again, this would have been a dotted line. I just didn't draw it as dotted. Okay, I know that's confusing, but you won't really see a lot of systems of inequalities. All right. At least not on the quiz. All right, moving on. All right, the last part of a system that you will see is in terms of circle equations. Now, when you get to math 3, you're going to deal with circle equations a lot. How do I know? I literally just saw it yesterday to my math 3s. All right. But circle equations in for us are mainly just in terms of systems. All right. So the general form of a circle equation is that if you're given the radius r and a center of x to the c, y to the c. So I like to say center of hk. All right. Your equation is given by this. So the nicer way of saying it is that x minus h squared plus y minus k squared is equal to r squared, where r is your radius and your center is the point hk. Now, do you necessarily need to know this? No. All right, not yet anyway. But it's kind of fun when you look at it in terms of a system. All right. So, yeah. So, in terms of identifying the center and the radius, so this right here is our equation of the circle. So, this is a circle. So, if I graphed it in Desmos, it would literally form a circle. All right. Now, another way that we could rewrite this so it looks more like the formula we were given is x minus 0 squared plus y minus 0 squared is equal to 25. And why did I do that? It's because, remember, your center comes from HK. So if there's nothing there, we're assuming that we're subtracting 0. There's not a 1. We're not talking about multiplication. We're talking about subtraction. All right. So if I wanted to say what the center was, what do you think the center would be? 0, 0. So you just take whatever's written here and flip the sign. So say if this was minus 1 plus 2, it would be 1 negative 2. The radius. So remember, it's r squared in the equation. So what would the radius be? 5. You just take the square root. So if I actually graph this circle, your center will be right here at the origin. And then for the radius, I say go north, south, east, west. So you would actually count out 5 from the center in each direction. So up, down, left, and right. Now, you don't connect them with lines. It just gives you an idea of what points your circles are going to go through. So if I drew the circle, it looks something like this. And it's not going to be a pretty circle, but, we tried. So you're just drawing the points that your circle is going to go through. Now, if we wanted to solve this system graphically by plotting the line, all right, so if I'm looking at this line right here, where do I start? Our y-intercept of 1, and then what's my slope? 1. So up 1 over 1, up 1 over 1, up 1 over 1. Just going to keep doing that for a while. Same thing in this direction. Now, just like with any other graphs, the solution to your system is the points of intersection. So we're thinking here and here. Now, because I didn't draw this circle perfectly, I still want to check in Desmos to make sure I got it correct. So in Desmos, I want to type in my circle equation. So x squared plus y squared is equal to 25. And if you notice, it actually does make a nice circle for us. And then x plus 1. So our points of intersect are at -4 is -3 and 3, 4. I think I actually did that correctly on the circle. I cannot believe it. Yeah, I did. What are the odds? Okay, so this would be, and it may not be perfect on the graph, on your graph, but this would be +3, 4, and this would be -4, -3. So if we solve the system xy is equal to, boys quit, -4, -3, and 3, 4. Now, that's if we solve it graphically, but we can also solve this system algebraically. All right. So, if we're solving it algebraically, we have to solve it using substitution. So, what that means is that if this is y equals and something in terms of x, what do you think I'm going to do if I'm talking substitution? Where? Where? And for y. So I'm going to plug x plus 1 in for y. So this would now be x squared plus x plus 1 all squared, because we still got to apply the function there, is equal to 25. So to solve it, we first need to expand this and combine like terms. So this would be x squared plus 2x plus 1 is equal to 25. So this would be 2x squared plus 2x plus 1 is equal to 25. And then what do I have to do with the 25? Subtract it to the other side. That goes away, and we're left with 2x squared plus 2x minus 24 is equal to 0. And so it actually does form a nice quadratic function that we can solve. So if we were to solve this by factoring, what would I have to do first? Factor out GCF of 2. So if I take that 2 out, I get x squared plus x minus 12 is equal to 0. And then remember, if we divide the 2 out, we can get rid of it because it doesn't have a variable in it. So this would be x squared plus x minus 12 is equal to 0. If I did a quick big X, this would be negative 12 and 1. Two values of negative 12 that add to 1. 4 and negative 3. So this would be x plus 4 times x minus 3 is equal to 0. Thus, our x values are negative 4 and 3. Now, those are our x values, so to get our y values, we have to do what? Plug it back into one of the functions. I highly recommend the linear one because all you got to do is add 1 to them. So y would equal negative 4 plus 1, so that is negative 3. And y would equal 3 plus 1, and that's 4. So when we solve it by substitution, we get the exact same answer that we got when we solved by graphing. Now, that's when it's centered at the origin. But if our circle isn't centered at the origin, that's when it gets a little dicey. All right? But we're still going to do it. So, solve the system shown algebraically. We're going to show all our work. And then we're going to check in our calculator to make sure we're correct. Okay? So, now, just for funsies, this center would be at the center negative 2, 4. And then the radius would be like something weird like square root of 40. All right? But we don't really care about that. What we do care about is if we can solve it algebraically. So what do you think I'm going to do first? Plug 3x plus 10 in for this y right here. So this would be x plus 2 squared plus 3x plus 10 minus 4 all squared. It's equal to 40. Now, before I can do some simplifying in terms of those squares, what do I need to do first? I can't multiply them out yet. Nope. I need to combine the like terms right here. All right. So this would be x plus 2 squared plus 3x plus 6 squared is equal to 40. Now I can expand. So you can do a quick box method for this, but if I expanded, I would get x squared plus 4x plus 4 plus 9x squared plus 36x plus 36. And that'll be equal to 40. Combine like terms, you would get 10x squared plus 40x plus 40 is equal to 40. And then what do we have to do to solve? Subtract the 40 first to get it equal to 0. That goes away. I get 10x squared plus 40x is equal to 0. And now this is a very easy factor because what's the only thing we got to do? not just a 10, but also an x. So we factor out GCF of 10x, and that'll leave us with x plus 4. So if I set both equal to 0, because our GCF has an x in it, what are my two answers? X equals 0 and negative 4. So these are our two x values, but I still need the y's. So I need to plug both of these back into one of my functions. I'm going to pick the linear because, again, it's way easier than trying to plug it into the circle. And if you look, we actually can't plug it into the circle. Why? So why do we have to use the linear function to find the y? Right, we don't have a y value, which is in the circle equation. So we have to plug it into the linear. So I would do 3 times 0 minus 10. So 3 times 0 is 0, minus 10 is negative 10. Oh, plus 10. Well, you know what? That's just a sign. Then 3 times negative 4 plus 10. 3 times negative 4 is negative 12, plus 10 is negative 2. So these are our two y values. So our system would be the point xy is for the 2 points, negative 4, negative 2, and 0, 10. So we're saying that this is our answer. Now, to check ourselves, I'm just going to do a quick check in Desmos. All right. So if I check this in Desmos, what do you mean? Because that's what I plugged in for x. So whatever you originally plugged in for x, that's what the y value matches up to. So like, do you see how I plugged in negative 4 here, and that's how I got negative 2? That means negative 4 and negative 2 go together. Yeah. Guys, please stop talking, or you'll have a seating chart tomorrow. So if I do a quick graph, this would be x minus, what was it, 2? X minus 2 squared plus, that's what I was asking y'all. Y, what is it, minus 4? Minus 4 squared, and it's equal to 40. And then I have y equals 3x plus 10. So if I zoom out a little bit and I click on where they intersect, it's exactly the points that we came up with algebraically. Any questions on doing systems with circles? It's not too bad, right? Now, with inequalities, if I asked you to do an inequality, I would just ask you to graph it and highlight where the system is. All right. Okay, last thing we're going to do is word problems. So now we're taking everything we just learned, throwing it together in word problems. Now, since we know how to do things algebraically now, guess what we're doing with these word problems? Solving them algebraically. Gone are the Desmos days. All right. So, now we're going to connect everything we just learned, so inequalities and systems, to real world applications. So at first, we're just going to start with what we already know with these real world applications. All right, so we talked about this back in Unit 3. All right, so let's look at exercise 1. So an object is fired upwards at an initial velocity of 112 feet per second. Its height in feet above the ground, and then as a function of time in seconds since it was fired. And it's given by this equation. So in other words, h of t is height, t is time. So our y value is height, x is time. Now, at what height was the object fired at? Nope. It's at 0. Why? There's no C value or constant, so we have to assume it's 0. So it was fired at 0 feet. Because that's what if we were looking at the graph, what would that be our? It's our y-intercept. So if I sketch a sketch of this curve, all right, we only care about if it's positive, so I'm only going to do it within the first quadrant. We're saying that it launched here, and it went up, 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 peaked, and then came right back down and hit the ground. And we don't know where it hits the ground yet. All right. So algebraically, we're going to find the time that the rocket reaches its greatest height and maximum height and label on the graph that we drew in part B. So if we're talking max height, what is that? The vertex. So we're trying to find this right here. Now, we talked about how to find the vertex algebraically. What's the easiest way to do that? Well, besides putting it in your calculator. So who remembers how to find negative b over 2a? Good. So we're going to start by doing negative b over 2a to get the x value of the vertex. So what's b? 112. So negative 112 over 2 times negative 16. This will be negative 112 over negative 32. It's negative 16 times a positive 2. The negative's in the b value. So we know our answer is going to be positive because we have a negative divided by a negative. But what's 112 divided by 32? You guys got calculators in front of you, right? 3.5. So we're saying that in 3.5 seconds, that's when we would reach our maximum height. So this would be 3.5. But now we need to find the y value. So how do you think I'm going to do that? Plug it back into our original function. So this would be negative 16 times 3.5 squared plus 112 times 3.5, which would equal what? Take a minute, plug it in your calculator.
Uh, 196.
So 196, that's what it is?
Yes.
So 196 what? What's the units? Not seconds, because it's not time. Feet. So it takes 3.5 seconds to reach a max height of 196 feet. So this would be 196. So that is our max. Now, algebraically determine the time when your rocket reaches the ground and label this graph in part B. So first off, if we're talking when it reaches the ground, where am I talking? The roots. So we're talking right here. This is when it hits the ground. But we need to find at what time that actually was. So, first things first, we're going to see if that top function is factorable at the very least, because that may give us an idea. So, if I have negative 16t squared plus 112t is equal to 0, what can I 100% factor out? I can factor out a negative t at the very least, because remember, we want our a value positive. And then does 16 go into 112? Yes. So we can factor out the 16. So this will leave us with t minus 7 is equal to 0. So if we set both of those equal to 0 to solve, we would get t would be both 0 and 7. However, Which one is the actual answer? 7. Why?
Because
Our launching point was at 0. So in reality, it hits the ground after 7 seconds. So 7, 0, it takes 7 seconds to hit the ground. Now, you can always use Desmos to check yourself. All right. So if you wanted to, you could graph that function and just double check that you got all of your features correct. But for the most part, you do, like, since you know how to solve it by hand, if you see a problem like this, try to solve it by hand. All right. Now, let's look at exercise 2. So a projectile has a height given by this function right here. A drone has a height given by this function. So if t is time in seconds and the heights are in feet, determine the two times to the nearest hundredth of a second that the projectile and drone are at the same height. All right. So if we're talking about two different things, we're talking about a projectile and a drone, and they're given by two different equations. What do you think this is going to be? A system. All right. So one's a quadratic, one's a linear. So what do you think we're going to do? Set them equal to each other. Negative 16.1 t squared plus 120 t is equal to 8.5 t plus 85. So we're going to solve this by hand. All right, and then check ourselves using Desmos. So if I solve by hand, I'm going to subtract the 0.85 t to both sides, as well as the 85. So this would be negative 16.1 t squared plus 120, not 120. What's 120 minus 8.5? You could, but yeah, let's do that. That's friendlier. You could, but honestly, we end up having to use quadratic formula anyway, so it wouldn't really matter. But just for, consistency's sake, we'll move this stuff to the other side. That goes away. We get 0 is equal to 16.1 t squared. Can someone do 8.5 minus 120 for me?
Minus 1100, but minus 111.5.
Negative 111.5.
Got it. Plus 85. Now, that is obviously not factorable, so we got to put it in the quadratic equation. All right. Now, since we're rounding it, once we get into the quadratic equation, we can just put it into our calculator to get the answer. All right. So this would be negative times a negative 111.5 plus or minus the square root negative 111.5 squared minus 4 times 16.1 times 85 all over 2 times 16.1. All right, so a lot of the stuff in the calculator that we got to do. And again, we want some rounding stuff, so we're going to do that first. So the goal is that we don't want to round until the very end. So the first thing I'm going to do is I'm going to type in just what's under the radical. So I have, and be very careful with your parentheses, negative 111.5 all squared minus, I'm going to put this in parentheses, 4 times 16.1 times 85. And I'm going to put exactly what that number is because it does cut off. So 6958.25. All right. So this would be positive 11.5 plus or minus the square root of 69. What was it? 6928? 58. 4.25. All over 32.2. Now, to be perfectly honest, all you got to do is separate the plus and minus already. So it'll be 111.5 plus the square root of 6958.25 all over 32.2. And then 111.5 minus square root of 6958.25 all over 32.2. And then just put that entirely into your calculator and get an answer. All right. So I'm going to do the first one. So I'm going to put this in parentheses, 111.5 minus, no, plus the square root of 6958.25, close the parentheses, divided by 32.2. And set to round to the nearest hundredth, so what is that? 6.05. So we're saying that this would be approximately at 6.05. And now I need to check the other. Now, instead of having to type all of that over again, here's a little trick if you're using a TI. If you hit second and then the enter key, it'll re-input your entire entry that you just put previously. So all I gotta do is go back and change that plus to a minus. So I just hover over the plus, put a minus, don't even have to type extra stuff in there, hit enter. So 0.87 seconds. Now, it wants to know when the projectile and the drone are at the same height. All right. So if it's saying when, that means we're talking about our x value, so we don't have to plug back in for y. All right. So you would use parentheses for this part and then divide it by that. They're already simplified. Now, I want to double check myself in Desmos. So in Desmos, I want to put in the two original functions. So I have negative 16.1 x squared plus, what was it, 85? Something? What was it? Plus 120t or x, okay. Then it would then be, okay, good. Now you're probably gonna have to zoom out a lot to see it. So if I click on it, here are my 2 points. So there are 2 places when the projectile and the drone are at the same height. All right. It's when it's originally going upwards and then when the projectile is falling. So, and it is about where we got our answers from. So we're going to say that they're at the same height at approximately 0.87 seconds. And I'm just going to make a note that say the projectile is going up. And at 6.05 seconds, and that's when the projectile is going down. The drone is constantly going up. All right. So the drone's constantly going up. We don't really know for how far, but I mean, feet wise, it was like 100 something feet. That's doable for a drone. All right. Any questions on that? All right, last one we're going to do. So, the Crazy Caramel Corn Company has determined that the percentage of kernels that pop rises and then falls depending on the temperature of the oil that is cooked increases. So, this model models the trend. So, this is our model right here. So, where P is the percent of the kernels that pop, and T represents the temperature of the oil in degrees Fahrenheit. All right. So, algebraic, we're going to determine the temperature which the highest percentage of kernels pop. And we're going to determine that percentage of kernels that pop at this temperature. So, if I'm talking about the highest percentage, that's the same thing as what? It's the same thing as its max. So, in reality, what am I looking for? The vertex. So, if I do this algebraically, what am I using? What's the formula? Negative b over 2a. So I would do negative times 2.8 all over 2 times negative 1 over 250. And guys, this you can just put in your calculator, but be careful. So in my calculator, I'm going to clear out all this mess. I'm going to do negative 2.8 divided by, and I'm going to put this in parentheses, 2 times, more parentheses, negative 1 divided by 250. I'm going to close the parentheses twice. Yep, so 350. So that's equal to 350 degrees. So that's the temperature of the oil. Now I need to know what percentage actually pops. So what do you think I'm going to do? Plug it back in. So I'm going to do negative 1 over 250 times 350 squared plus 2.8 times 350 minus 394. So if I do that, I'm just going to put it in my calculator very, very carefully. So I have negative 1 divided by 250 times 350 squared plus 2.8, 2.8 times 350. And what was it? Was it plus or minus 394? Minus 394. So 96. So we're saying about 96% of the kernels pop at 350. So 96% of kernels popped at 350 degrees. Or in 350 degree oil. Guys, please stop talking. Now, we're going to sketch a curve given what we know. All right. So, I'm going to use Desmos for this. So, you could use your graphing calculator, but honestly, Desmos is easier. So, I have negative 1 divided by 250 x squared plus 2.8x minus 394. Now, we only care about what part of the curve? The positive part of the curve. So in other words, we only care about the curve when it's doing what? It's above the x-axis. All right. So if we label this, all right, we want it above the x-axis. So I'm saying this starts at about 195, goes up until we hit our max, and then comes back down at, it was about 505. And our max was 96,350. And we already determined when our two temperatures, and they want it to the nearest degree. So we want to know when our two temperatures are at P equals 0, so no popping at all. So P would have to be, or not P, T would have to be 195 and 505. And that's actually an approximation because we had to round. So make sure if you do an approximation to write that squiggle equal sign. Now, if a typical batch of popcorn consists of 800 kernels, how many does the Crazy Caramel Corn Company expect to pop at optimal temperature? Now, what does optimal temperature mean? 350. So in other words, optimal means when we get the highest amount of corn. So we're talking 350 degrees. Now, how much of the popcorn did they say would get popped at 350 degrees? 96%. So how do I figure out how many kernels actually gets popped? 800 times 0.96, which would give you what? 768 kernels. So they're saying about 768 kernels will pop. If I can actually spell correctly, that'd be fantastic. Will pop if it's at the optimal temperature. Now, last part. So for each batch of popcorn to be successful, the company wants at least 85% of the kernels to pop. So we're going to write an inequality whose solution represents all the temperatures and ensure that we have a successful batch. And we're going to solve this graphically to the nearest degree. All right. So we're going to solve this graphically because we already know what our x-intercepts are, but points of intersect, we're just going to do this graphically. So first off, let's write an inequality. So of course, we're going to have our original function, so it'd be negative 1, 250. I'm going to use x instead of t, so x squared plus 2.8x minus 394. Now, think about how our answer was back in letter A. If we're talking 85%, did they write it in terms of a percent, so like as a decimal, or did they write it as a whole number? Whole number. So when we did it up here, when we plugged back in, we got a whole number, not 0.96. All right. So we're assuming that when they say 85%, we're actually going to set something to 85. Now, what does at least mean? What sign do you think I'm going to use for at least? Greater than or equal to. So we want at least, meaning at minimum 85% of the kernels to pop. So it has to be greater than or equal to. Now, if we want to graph this in Desmos, what we're going to do is we're going to separate these to figure out what's going on graphically. So in other words, we're going to set both of these equal to y. But in reality, if we want to be greater than or equal to 85, we want to include the symbol with the number. So this is going to be two separate equations. So if I go back to Desmos, I got the original already put in. Now I'm going to put in y is greater than or equal to 85. So if I look at my graph, my points of intersect are here and here. Ugh. So if I zoom in and look at my graph, my points of intersect are here and here. And it's a very small window of where it falls. Okay. So if I round this will be about 298 and 402. So let's go back to our graph. So just to kind of give us an idea what's going on, 85 is right here. So this is 85% of the kernels. And it's shaded right here. And here, that's where X was equal to 298. And here, it was about 404. So in terms of temperature, what temperatures does it have to be around for it to at least 85%? Is it going to be between those two numbers or less than or greater than those two numbers? Between those two numbers. So how would I write it? So in other words, if it's between, am I going to write it as a compound inequality or two inequalities? Compounds. So I'm going to throw my less than or equal to's on either side because it has to be between. I'm going to say 298 and 404. Now, if we wanted to state it in words, we could say the temperature of the oil has to be between 298 degrees and 404 degrees in order for 85% of the kernels to pop. I'll move it up. Yes.
How do you know if it's like a compound equation? Answer.
So compound inequalities you can only write for in between. So if it's in between the two numbers. So in other words, the shading is literally in between the two numbers. Whereas you write them separately or as an or statement if it's like one side and the other. Yep. Yeah, 402. You know, it's fine. Apparently I have no memory for like 2 seconds. All right, so your homework for tonight is pages 11 through 13. So you're finishing up the packets. You got a solid 15 minutes to get started on it. Now, one thing I will mention for these two, all right, on your homework, it's systems of inequalities. I just want you guys to sketch where the solution set will be. All right, so you can use Desmos, but you need to sketch where the solution set will be. So in other words, you don't need to tell me where the solution set is. I just want to see the graph of where it would be. Any questions, guys? So you're basically just finishing the packet, yeah. But formally, it's pages 11 through 13.
Okay, I have a question about my homework.
Uh
I
huh.
got like a 1 out of 3 on.
Uh huh.
Like, what can I do wrong? How do I do wrong?
It's more so if it's something that I need to see work for, if I don't see it, or if it's not fully completed, that's when I take off points.
But remember when you were checking, you said, did you do your work? And I said,
That was a different homework. Different homework.
Can I pull it up?
Sure.